Hello everyone, good afternoon. Welcome you all to the workshop today on data science. I hope I'm properly audible to all of you. You can make use of chat box or the question box on the right hand side panel of your GoToWebinar platform and reply me up. So yes, I can see the reply from Shubham and Mukul that I'm properly audible to them, and I expect that I'm properly audible to all of you. So good afternoon again, and thank you for the confirmation, and welcome you all to this workshop. So we're going to be today talking about data science. So today's session is going to be more on the idea of understanding the concept of data science and understanding the set of applications into it, and the terminologies, getting good with the data science pipeline. And once you're good with that, we'll be working with a couple of one practical problem tomorrow. So in tomorrow's session, which is a continuation of this workshop, we'll be looking at a practical implementation of a data science project on a data set we will be discussing up today. So in this today's workshop, we'll be looking at some basic idea of data science and working with practically using Python programming, practically working with one example. Right. So let's get started. At any point, if you have any question, please submit that up. If the question is not relevant to the current topic, I would recommend you to keep that at the end. So here we go. So we're going to be talking about what exactly is data science. So first thing, data science is about, if we look at a couple of examples of data science, let's say that, if I take you to sort of a couple of portals here, right? Let's say Amazon Prime, if I take you to that, or if I take you to Amazon, right? And maybe if I can take you to sort of, let's say, YouTube, all right? So on YouTube, if I go ahead and kind of watch a video, let's say, maybe if I go to a sort of, let's say, news video. I'm watching this video.
Is disappointed with this decision that Gibraltar.
So when I'm watching this video, I'm getting recommendation of a couple of other videos on the this particular right hand side panel, which are quite related to this US threatens to sanction over Iran tanker, and this is all of the news articles which are quite related to that. So when we are watching a particular video on YouTube, YouTube pulls up a lot of other videos which are quite related to this and shows up as a part of recommendation to us that we can watch these videos, or we may be interested into these videos as well. We call it recommendation system. So based on the video that I'm currently watching out, I'm creating certain data that I have interest into US sort of videos, or let's say US threatening the Iran tanker, Iran. In this political topic, I have interest, so it's going to be bringing up a lot of other political topic and showing up the other political news or videos over here. This is what we sort of call as recommendation. And if I log in with my YouTube account, I can get recommendation which is more relevant to the the current topic or the history of videos that I have seen in the past. If I go to Amazon Prime here, I can see the recommendation of videos which I may want to watch, which is Bosk or when Helsing, or maybe searching or like this, right? So these are all the videos which are being recommended, let's say, might be based on the past movies that I might have seen on Amazon Prime. And also the posters of the movies, let's say that, if a particular movie is being recommended, Harry Potter over here, if this would be in a category of romantic movies, maybe, a romantic poster would be shown over here. So what happens on Amazon Prime, when we watch a movie, the movie might have certain data tags like romantic or maybe thriller, or maybe it might have a tag associated with that. It's a sci-fi or it's a fantasy. or it's a very slow movie, it's English movie, or it's by actor called Akshay Kumar, or maybe actor called Leonardo DiCaprio, or maybe you know uh, Emma Watson, the actress called Emma Watson, or anything like that. Every movie or every item has a lot of tags. Based on all the past movies that I have seen, the Amazon Prime algorithms tries to categorize me into community of those people who have similar to me likes and dislikes. And based on that, it keeps on recommending us different movies over here. By recommending us different movies, Amazon tries to increase the user engagement. So, in a nutshell, whenever we watch any movie on Amazon Prime or Netflix or video on YouTube, we create data about what we like and what we don't like. Based on that data, they use that to showcase us different other movies and keeping the user more engaged with the platform. Similar way, if I go to Amazon and I search for any product, right? For example, let's say if I search for a laptop and I kind of click on this laptop, let's say. So with this laptop, I'm going to get recommendation of other laptops, or as you can see that frequently bought together. So those people who bought this laptop, majority of them also bought this bag. So it is trying to recommend me that bag because it's more likely that those people who have been buying this laptop have been buying bags. So I would also buy this bag. So it is using the data created by the users when they were buying laptop. They created that, okay, I'm buying this laptop, I'm also buying this bag. It used that data to identify the relationship between the product. And whenever you buy a product, it will also recommend you another product that you may always want to buy. That's how increasing the sales. We also getting, you can see customer who viewed these items also viewed this. This is also data. So when I see this laptop and I see another laptop, Amazon will record that I have seen item number 456 and item number 128 5. So the algorithm will try to link that, okay, those users who see this laptop, they also see these bags or laptops as well. So based on the based on the items that people or the customers would have seen on Amazon, it has created some patterns and is making now recommendations. This is what you call a recommendation system. So one of the very big asset that Amazon has this way, or for product recommendation, or the Amazon Prime has for movie recommendation, or YouTube has for video recommendation, is data. Data is what enabling these all big organization to be able to use that and make use of data-driven model of business to put more better advertisements or engage more users. The use of data after applying mathematics or science on the top of it, leveraging that for helping businesses to improve their business efficiency, is what we call as data science. So data science is a field wherein we utilize data. On the top of it, we apply maths, we apply science, and uh, we identify some patterns, some insights from data, which ultimately helps business to improve their business efficiency. And the whole field is called as data science. So the idea of data science is use some statistics, probabilistic, programming, mathematics, linear algebra, all these methods to extract information or to build something useful from the data for business, right? That's the whole idea of data science. So what are the role of data scientists in industry? In industry, a data scientist could play a role of statistician, where the data scientist should be able to identify right statistical methods to be applied on data. Uh, a data scientist needs to be a good programmer, where the data scientist needs to be able to identify what programming techniques to be used to implement on a particular use case. A business analytic practitioner, a data scientist, works also as a quality analyst to check that what sort of products are being manufactured which are not good. Uh, Mathematician, machine learning scientist, the actuarial scientist, the digital analytic consultant. A data scientist plays multiple roles in industry, and it's a role which is now has come up from the big giant organizations like Google or Facebook or Amazon to almost every small and medium scale industry. So today, even like you might have observed, IRCTC uses data science to predict the chances of a ticket getting confirmed. Right? You use data science; they use data science there as well. right? Other than the retail businesses and all, Big Bazaar, DMart, more, they all use data science to identify that how should they place the product so that the chances of customer picking more products could be higher. You might have observed on the checkout counter, they put chocolates and all those products. Those are small products, and the chance of customer picking those products is higher when they're doing checkout. That's also data science. The optimization of product placement is done on the basis of data science. Data science is widely used in astronomical physics as well. If you might have heard recent news about drawing the picture of a big black hole, right? That was more on collecting data from different sources and using neural networks, which is machine learning algorithm. The shape of black hole was observed, which is astronomical analysis, and that's where data science is heavily used. So a lot of these companies starting, whether they are from banking, finance, from manufacturing, healthcare, or from avionics, aeronautics, from retail or government organization, into constructions or mobility or automotive, all of these businesses collect huge amount of data. So in over past years, digitalization has contributed a lot to the large volume collection of data, and that has led the enterprises to be capable of applying science on the top of it and using that in business. So data science is all about that. Data science uses a lot of fields from statistics, machine learning, and a bit of deep learning, to sort of build some models, and to use data to build some models or build some solutions which could benefit the business at the end. So if we talk about sort of relationship between artificial intelligence, and these are a couple of words that we keep on hearing up in real world day-to-day life, which includes artificial intelligence versus machine learning versus deep learning and data science. If we talk about sort of comparison of these terms, so in general, if we in short talk about the uh, sort of comparison, maybe if you have attended one of the other workshop previously of machine learning, you might have seen some similar chart, but yep, we're going to be sort of looking at a quite similar chart here with understanding on what exactly is data science. Right, so here we go. Right, so this is where we're going to be just looking at a quick overview of Venn diagram, and we're going to be making ourselves clear with the terms, which we, wherein we understand that what exactly is data science and how is it related to other popular terms like machine learning, deep learning, and artificial intelligence. How is it related to these terms as well? So let's have an idea on that. So we're going to be talking about a couple of terms here. One of them is artificial intelligence, machine learning, deep learning, data science. How are these all terms related, which is what we can discuss here today. Okay, so let's say that we're going to first talking about the popular world of artificial intelligence. What exactly is AI? So artificial intelligence or AI is about making computers or machines act more intelligent, make computers as intelligent as possible, right? Like, or making computers act more intelligently, similar to the way we humans act, right? So that's the idea of AI. So you can say AI can be defined as more of making computers act intelligently like humans. And technically, how do we do it? Technically, it's more of collection of algorithms, right? So logically, the idea of AI is about making computers act intelligently as good as humans. And technically, how do you do that is technically AI is more of collection of algorithms. So since 1950, there has been development which begin up from 1950. There has been development in the field of artificial intelligence. Since then, a lot of researchers across the world developed a number of algorithms. Today, when we say AI, it's a collection of such algorithms which can be used to make computers act as intelligent as humans. When we say intelligent humans, what do we mean by that? Well, you can say that like the way we humans can recognize our friends and family members by their faces, if we can make computers do that, which is what we call face recognition system. If we can make computers recognize faces using camera, that's AI. The way we humans can understand multiple languages, if we can make computers understand multiple languages, which is what we call machine translation, that's AI. The way we humans can identify multiple speeches and read handwritings, if we can make computers read handwritings and identify multiple speech and convert it into text, that's AI. AI is all about making computers act intelligently like humans. How do you do it technically? Technically, it's a collection of algorithms. Then, so you can say that it's umbrella of algorithms. There are many algorithms under AI. One of the algorithm under, I mean, some of the algorithms which are very powerful and are part of AI, but they use data to build intelligence, and such algorithms are called as machine learning. So machine learning is another term which is subset of AI, which is part of AI again. So it is not something very different than AI. And what we do here is machine learning is about algorithms which use data to build intelligence, right? Or you can say the algorithms which learn from data, right? That's what we call as machine learning. So machine learning is a subset of AI, right? Not very different than AI. So when you're doing machine learning, you're actually doing AI. And these are algorithms which are most powerful segment of AI. So you can say under AI you have a lot of algorithms. Some of them use data, some of them do not use data. Those which use data are part of ML and are very powerful algorithms. Those which do not use data are not part of ML and not as powerful as ML algorithms. Then there is another algorithm, set of algorithms called deep learning. So deep learning is another set of algorithms under AI and subset of machine learning. It's a subset of ML. So you can say deep learning also uses data, and most advanced part of ML AI it is. And the technically way it is different, which we are not going to focus a lot at this point of time, is that deep learning algorithms perform automated feature extraction. So that's not our focus at this point of time, but yeah, just for terminology's sake, they have some difference. As deep learning is a subset of ML, deep learning also uses data. Today, very popular applications like self-driving car, like chatbots or traffic sign recognition, these many applications are based on deep learning. So today, the most advanced segment of AI is nothing but deep learning. Right. So that's that sort of idea of deep learning. Now, when we say machine learning is a field where we kind of use data to build intelligence. A similar field, where we kind of use data and perform some sort of analytics on the top of it. We call it data analytics. So that's another field, wherein what we do is this field also uses data. But what this field does is this field, in this field, we call it simply data analytics. So what this field does is it simply uses statistics and probabilistic analysis, statistics and probabilistic analysis, and it also uses something called data visualization. And that's how we use it to extract some insights or patterns from data. So this field is called as more of data analytics, wherein we use statistics and probabilistic analysis on data, and we use visualization to identify some past patterns, what happened in the past or why did it happen in past. And this field is called as data analytics. For example, let's say that here, if I have this data, let's say I have a data available from a bank, and this data is coming from 10th bank, and the bank has provided us data of 10,000 customers, right? So let's say from the bank we have data of 10,000 customers of the bank. For every customer we have our own number, we have customer ID of all the 10,000 customers, we have surname of all the 10,000 customers, we have credit score which is from 300 to 900, we have geography, right? In credit score is much more like CIBIL score in India. We have the similar way we have credit score here. Geography, where the customer is from. Customer France, Spain, Germany, like that. What is the gender of customer? Customer is female or male or female, like that. Age of customers, tenure. That means how many years it's been the customer is associated with the bank. Balance, the minimum balance reported in the customer's bank account. Number of products, one product, three product, two product. That means one product means only a savings bank account. Three product means savings bank account plus an insurance or a mortgage. Two products means we can say savings account plus mortgage only, maybe. So then customer has credit card or not. So one shows yes, customer has credit card. Zero shows no, customer doesn't have credit card. One shows yes, customer has credit card, and zero shows customer doesn't have credit card. Is customer active member or not? So one shows yes, customer is an active member. Zero shows no, customer is not an active member. One shows yes, customer is an active member. That means customer might be doing some significant number of transactions in every, in last 6 months. Estimated salary of the customer. What is the estimated salary of the customer? And then at the last, the column shows that whether the customer left or did not leave. So one shows the customer left the bank, and zero shows the customer did not leave the bank. So in last 6 months, the bank observed that a lot of customers started leaving them. This column shows that data. So one means the customer left, and zero means no, customer didn't leave the bank. One means yes, customer left the bank, and zero means no, customer didn't leave the bank. So the bank is worried why customers are leaving them, and they want to identify why did it happen. Why so many customers started leaving them. That's where we can use data analytics to tell them that, well, maybe all the young age customers are leaving, the old age are not leaving, or maybe all the females are leaving, males are not leaving, or maybe all the customers high credit score are leaving, low are not leaving. The customers who do not have loans are leaving. The customers who do not have credit card are leaving. There could be a number of patterns which we can identify from the data and tell the bank that this could be a reason why people might leave the bank. Right. So that's the idea of data analytics. Right. So data analytics is all about you bring in the data, and on the top of it you form some analytics to identify some past patterns. Right. So this is the field of statistics or data analytics. For example, let's say that a simple idea could be, let's say if we look at the age, average age or mean of age of customers who left the bank is 65 years, and mean of age of customers who didn't leave the bank, their average age is 35 years. Right. So we can easily say that, well, looks like average age of those customers who left the bank is 65 years, and average age of those customers who didn't leave the bank is 35 years. So looks like more of old age customers left the bank. So using this statistics, we can say that, well, looks like majority of the old age customers left the bank, or majority of the customers who left were having old age. That means we can say that it looks like that the bank may not have attractive offers or the offerings to meet the financial goals of old age customers, right? So that's the idea about how do we use statistics to analyze the patterns, right? So yeah, I hope you're good with that. Now the combined part of this two things, the idea of uh, if you combine these two things, machine learning and data analytics together, the combined segment is called as this combined segment is called as data science. If I combine these three things together can be thought of as data science. Right, so data science is combination of data analytics on the top of it, applying machine learning. Right, so that's what we call as data science. So data science is a combination of these three things, you can say: data analytics, which is statistic and probabilistic and visualization, plus machine learning and deep learning, a little bit of deep learning, not much of it. Right, so in the same data, what we can do is we can use machine learning right over here. So first we can use analytics and identify why the customers left the bank, what made the customers leave the bank, and then on the top of it we can use machine learning to build a model which should be able to predict that in future which of the customers are going to leave the bank. Right, so that sort of idea is how to use machine learning. So this combined field is called as data science, but here we mostly talk about the data which is available into structured format, which is available in the form of SQL databases or Excel sheets or CSV files. The similar way, when we talk about data, it could be also available in other forms as well. If the data is available in the form of images, we do something called image processing, which is very different from the statistical analysis. So if the data is available in the form of images, this is when we do, when we have images and videos without audio, we perform image processing on the top of it. When you combine image processing plus machine learning, the combined field we call as we call it more of as computer vision. The combination of data analytics plus this, it is called as more of computer vision. Similarly, if you combine this, when the data is present in the form of text, let's say the data is present in the form of text, right? So that's where data could be present in the form of text or audio, and on the top of it, if we apply AI or machine learning, we say that combined field is called as natural language processing. So the point is that our restriction and the scope of data science is on structured data, right? So we call this as more of NLP, right? So this field is called as natural language processing. This combined field is called as NLP. So these are the three fields how the industry uses the the use of artificial intelligence, machine learning, and deep learning industry. So the field that we are focused on and we are interested into is data science, which is all about on the structured, unstructured, and semi-structured data, mostly structured and semi-structured data. We perform some sort of analytics and mathematics and analysis to build the models or the solutions which could add business value, which could help the business, to improve the business efficiency, right? So that's how the relationship between multiple terms is. Let's have a quick recap. If we talk about so data science is sort of combination of the three, well, applied on the top of structured data and after applying stats and data visualization and probabilistic analysis. right? So artificial intelligence is about making computers or machines act as intelligent as humans, right? And it broadly tries to imitate the human intelligent behavior, like human way of driving a car, recognizing human faces, identifying objects, or converting speech to text, understanding multiple languages. AI is all about copying such human intelligent or human capabilities in machines. Machine learning is a subset of AI, which talks about the set of algorithms which can make computers learn from data and can be used to build intelligence. Technically, you can say AI is a collection of algorithms, and those all algorithms which can be used to build intelligence and also uses data are part of ML. Right, so here in ML, in machine learning, we train the ML algorithms from data. The algorithms learn the pattern, and then they can make predictions for any new data point. Deep learning, one of the subset of machine learning, or one of the set of machine learning techniques. There is an algorithm in machine learning called neural networks. Modifications of neural networks are widely considered as deep learning algorithms. The most advanced part of AI and the most powerful part, and all the algorithms are modifications of neural networks. So this is the advanced part, and we computationally very expensive. You need huge amount of data to train and use GPUs and all. Data science, combination of almost everything together, bundled and used for adding business value on business structured data. So main focus of data science is on preparation of data, engineering of features, and statistical and probabilistic analysis. On the top of it, applying ML or DL if required. The applications of data science are a lot. The one we see, recommendation system, internet search, the one moment you do Google search, that's also data science. Recommendation system on Amazon or Netflix or YouTube is data science. Advertisements that you get to see on Google or other platforms, that's data science. Recognizing images, recognizing speech, right? Comparing multiple prices of products on the websites, the route planning in the flights, dynamic pricing, detecting frauds in the credit cards, and also rightly delivering the logistics. These are all examples of data science applications. Now, TPU, this is a question, what exactly is TPU? TPU stands for TensorFlow Processing Unit. So TPUs are developed by Google to make the deep learning application easily deployable. So in case if I have to, train a deep learning model based on GPU, I can train it in my laptop, but I cannot, use this much of computational capacity to deploy a deep learning model in production. That's where I can use TPU chips, TensorFlow processing units, and train my model on the top of TPU and deploy it with the TPU. So this is why they use in deep learning and one of the alternative of GPU. Okay. Talking about data science, I hope that answers the question, Animesh. Talking about data science versus data analytics, if you meaningfully compare that, data science is more of an R&D oriented job, which is where it talks about identifying new opportunities, and you have to get your own questions and answers. Whereas uh, data analytics is more about following a process, which is already known. So let's say that, if I sort of create a standard methodology for banking problem. So whenever there's a churn in banking, you have to look age and look at the age less than 40 or more than 40, or credit score less than 40 more than 40, 400 less than more than 400, like that. So whenever there are some predefined methods to be applied on data and you have to extract some pattern, that's what people call as data analytics, where you don't do R&D, you don't use something very new, you don't have to go out of box. Whereas data science is where more of R&D job. You are not told what to do and how to do it. You have to identify right question, right solution, right path, and get to the most optimum solution out of the problem. And that data analytics very less of the times uses machine learning. Data scientist has to have very good understanding of machine learning plus data analytics both. Data science, you deal a lot with unstructured and structured data, and you have to do a lot of cleaning and preparation modeling of data, whereas data analysts need not to do that. Data science involves a lot of problem solving, capturing ingenious data, and handling that out. The programming languages, top preferred programming languages. So the preferred programming languages used for data science are Python, R, SAS, MATLAB, Java, and C. Out of them, the most popular programming languages include Python and R. R and Python are the two top choices of data scientists across the world. People who strictly deal with only statistics and logistic analysis prefer R over Python, but R is less deployment friendly. Python is more deployment friendly. So in case you have to deploy a product, Python is more deployment friendly. Python is more friendly to deep learning and high advanced NLP and computer vision applications as well compared to R. So one of the top choice, you can say, if I have to rank or if I have to choose one from Python or R, I would be choosing Python. But yes, both are the popular ones. So based on this, we have seen the idea of data science is more of collecting the information and building solution out of the data. Right. So this question, what to do with data? What do I do in data science? So the idea is that, well, you collect information, identify insights. So how do we get information from the data? The approach could be multiple of them. For example, well, it could be maybe a standard human approach where I look at the data and maybe I can say that, well, this doesn't make any sense and it looks like I should sort of look at the relationship between, if the customer's not an active member, it's much more likely the customer is going to leave the bank without applying stats. You look at human approach. If customer is not an active member, that means customer is not using bank account from very long. That means it's more likely the customer is going to leave the bank. This is more of human approach via which you select that where I would want to perform my research. Then on the top of it, you apply stats, right? Human approach makes it very filtered, and then you can apply stats to look at, well, what statistics says, comparing multiple means or variances of the groups of data points. You can also gather a lot of knowledge about data, right? What data says, looking at visualization of data, applying a number of mathematical techniques on data, like maybe clustering from machine learning or maybe hypothesis testing, right? Or comparing means, variances, looking at standard deviation, coefficient of variation. These are multiple mathematical other techniques which could be applied, right? Or using different programming tools to extract information from data, right? These are multiple methods to extract right information from data. For example, let's look at this particular use case here. So this is one of the use case.
Looks like in the studio, it's actually 3 a.m. in the morning. And again, I have a flight to catch in an hour. Now, if only I could book a cab. Shit, this driver again canceled my trip. Now, this is the
So let me play it from
time
beginning.
my trip has been cancelled. I'm just curious as to what to be quick about this because I have a flight to catch. And regardless of what it looks like all right, so we have to be quick about this because I have a flight to catch. And regardless of what it looks like in the studio, it's actually 3 a.m. in the morning. And again, I have a flight to catch in an hour. Now, if only I could book a cab. Shit, this driver again canceled my trip. Now, this is the sixth time when my trip has been cancelled. I'm just curious as to what is happening. Why are all they cancelling my trip? So is there anyone who can help me? I need to really figure this problem out so that I can catch my flight.
My name is Sai Alluri, and I lead the business analytics team at Uber India. So we do a lot of
The
work
use case from Uber,
with
and you're going to be looking at that how Uber uses data analytics and how did they solve one of the very popular problems.
Specific business problem that we're looking into today is around the airport case study that we started working on. So this is a real life problem that we face in one of our cities in terms of understanding how is the marketplace held from demand and supply working at airports and to airports. So when we look at data at Uber, right, so it might start off with an anecdote in terms of identifying what this problem could be. Could either be from customer tickets or from ops real hand, and understanding that airport reliability is not optimal. There's some issues with customers getting trips to the airport, right? So that's the unstructured bit in terms of understanding what the problem is coming from. The structured data actually starts with then understanding, looking at our data set. Most of the data that we use from an analytical purpose is stored in our warehouse, data warehouse. And from there, we have various tables that we can get specific trip level information to driver level information. This level of information helps us to understand exactly which trips are happening to and from the airport and specific characteristics of those trips as well. So if you want to understand exactly how long does it take for you to get an airport trip, either from the city or from the airport? And once you get that, once you make that request, how likely are you to actually go ahead and complete this? So that all that information you can query from our data warehouse.
So we have all of this data available, and that's a good start. But one question still remains. How can we use all of this data available to book me a cab? And as you can see, I'm still here and I don't have too much time left. But this seems to be a major problem. What am I doing wrong? How can we fix this problem organically? What can we infer from all of this data?
Yeah, so some of the key metrics that we look at Uber India specifically is completed by request. So this is a metric that tells you the reliability of how well the marketplace is, right? So specifically to this airport problem, we look at different points of the day from 4 a.m. to midnight, understanding at which hour do you get, are you getting requests, and what is the percentage of them that are getting completed, right? So a higher completed by request ratio means that there's better marketplace health in these areas compared to lower ones when there's not enough supply to meet the demand. So once we started looking into this data, right, so it was very interesting was we saw that cancellations that were going to the airport were higher compared to the overall cancellation rate for regular trips, right? So once you start looking into the problem, you'll understand that airport trip in itself takes a long time for the driver to get to the airport. And once that happens, so let's say it's like an hour and a half to get to the airport, there's an amount of time that the driver has to wait at the airport before he can get a trip back. Right? So since he's already spending this much effort, gas mileage and everything going to the airport, it doesn't make economical sense for him to come back empty. So then once he's there, he has to wait for another trip to come back. And based on the flight patterns that are coming into and out of the city, there could be a huge variance in terms of when he'll be able to get his next trip based on the flights that are coming in. And then the other metric that we're going to look into is specifically for this case study is the driver idle time at the airports. So meaning that once the inflow goes into the airport from the supply, how long does a driver have to wait until he gets a trip from the airport back to the city? Essentially, how much time is being unutilized by the driver where he could have been doing trips if he was not at the airport. For example, if he goes early in the morning,
So
4 a.m. or 5
that's
a.m., the first flight that might actually land is around 8 or 9 in the city, right? So within those 1 or 2 hours, he has to be waiting.
So this was one of the use case by Uber, and which was on data analysis. So what they identified is like how's that they have been using data analytics or data science into their business. So one of the problem in Mumbai was many of the cab drivers were canceling their cabs. In order to identify the issue, they looked at analysis of data, so source and destination, the kilometers and the driver type and everything like that. They identified that most of the cabs which are getting cancelled are going towards airport in the morning. The reason was that the drivers were not getting the return ride, the return customers, because there was no incoming flight, only outgoing flight in the morning. So that was my main challenge. So they did some solution. They first could identify this problem, and then they identified some sort of solutions to this by adding some extra. If you are traveling to airport in the morning, you will get higher airport fare compared to you're traveling to airport in the late night or maybe in the evening. So almost every business running from Ola, Uber, right, in order to predict the fare of the ride, they used a lot of data science into it, machine learning into it. So data science and machine learning is widely used to, you know, it's widely used to identify the insights of what happened in the data, and yeah, Varshita, you should be getting that, and you can connect for more details on that to the support team or sales team or your point of contact as well. Okay. So there are multiple, machine learning algorithms available, which can be used in data science, which are part of, the script or predictive algorithms used for different set of problems as well. So we get different types of problem in data science to handle, which could be part of classification problem or regression problem, right? And also classification is where you want to try to predict a output, which could be a categorical variable. Regression is where categorical variable, in the sense you can say that all possible outcomes. For example, if I want to use machine learning to build a model which should be able to predict whether the customer will buy a product or not. So there are two possible outcomes which we know, right? Yes or no, whether customer is gonna buy product A, B, or C, or D. So there are four possible outcomes for a customer. if whether the customer will leave the bank or not. So there are two possible outcomes, 0 or 1. Right. So in situations where you have countable set of possible outcomes, we call that as a classification problem. In situations where we don't have countable outcomes, the outcome could be any numerical value with, let's say, that what would be the salary of customer, or maybe the output could be how many kilometers the car will be able to go given a particular air pressure value and the speed with which car is going ahead. That's called a regression problem. So there are two types of problem in data science: classification and regression, which is more of predictive modeling problems. So more commonly used widely for forecasting is regression. Let's say what would be the housing price after 5 years? What would be the price of a stock in share market tomorrow? So these are all numerical values, and you can't have 5 to 6 or 7 or 10 or 20 or 100 values as in possible answers for this, right? You can't have countable possible answers for these problems. Like what will be stock price tomorrow? So you can't say that, well, stock price of Tata Steel tomorrow will be 5,000 or 6,000, 7,000. Well, it could be anything like 5,444.668899. It could be any numerical value. So that's regression. Classification is where you have something uh, where there is a possible outcomes are known, right? For example, we know all possible outcomes as 5 or 6 if you're trying to predict whether customer will leave or not leave. That's classification. The other type of problem is similarity matching, which is like clustering, finding out similarity between the products, whether two products are quite similar or not similar to each other. Excuse me, I'm sorry. Right, so that's called as clustering. Clustering is the other third type of problem we get in data science, which is more about identifying similarity between the products or similarity between the items or observations. Right, so that's called as clustering. Data science also heavily uses data visualization to make sense out of data. Visualization, we'll be looking at the idea of visualization, how visualization can be used or is being used tomorrow's session, which will give us a very clear understanding of data visualization. So visualization helps a lot because in a number of cases you can't explain mathematics to the business team, right? So I can't go to the business saying that, well, these are 10 or 20 numbers which shows that the sales will be high. They won't be able to make sense out of it, right? So in such a lot of cases, in order to be able to explain our research or findings to the business team, it is very important that we have a good cop up or good sort of skills over how to rightly visualize data or how to showcase the pattern using data visualization, right? So that's what we sort of call as data visualization, when we kind of use visualization techniques to visualize some patterns. It may be a simple histogram or a bar plot or a line plot, right? Or maybe a pie chart, right? So these all techniques can help us to visualize some patterns in the data. There are a lot of other advanced visualization techniques: heat maps, swarm plots, bar charts, right? So we'll be looking at a couple of examples of data visualization tomorrow while taking the data set as well, right? So after all this, if we try to analyze the whole process for data science, how do we start with that? So in general, we can start from the the real world problem, from where we collect raw data. We process the data, which includes cleaning of data, which includes scaling, pre-processing, encoding data points into some format. And then after the clean data, we feed it to the exploratory analysis, where we identify as much as patterns as possible from the data. The patterns like age stage is impacting credit score has no impact for customers leaving the bank, or maybe the patterns like the salary is a very impacting factor for customers leaving or not leaving, things like that. Analysis of such patterns helps us identify what is the right qualitative data to feed to a ML model or maybe a data science model. So then we feed the right qualitative data to an algorithm. From algorithm, we analyze the report. We make decision whether the model is good to be deployed or not. If it is good, we convert that into final product. So there's a life cycle of of a data science project. How does it get into? So there's a question, clean data, what exactly is that? Well, cleaning is about your data might have a lot of missing values. So let's say I have data of 10,000 customers. For 5 or 6 customers, I don't have their age. For other 5 or 6 customers, I don't have their salary. For other 5 or 6 customers, I don't have their some other value. Or maybe I have a lot of duplicate customer rows as well. So this is where we get a lot of messy or discrepancies into the data. And to be able to clean that, or to prepare that data very well, we need to perform cleaning. We need to replace missing values by mean, median, or mode. Maybe we need to drop those rows where we have missing values, right? So that's what cleaning. You get a lot of discrepancies. Let's say if the customer, somebody is collecting data in the bank, right? If the age is not available, they'll put hyphen or dash, or question mark on the in the place of age. So we need to remove that to be able to process it. So that's where these all things come under cleaning of it. Maybe for age, somebody who put a -20 value. Now age cannot be a negative value. For salary, somebody has put -30 value. That could not be a possible value, right? So there could be a lot of discrepancies into data, a lot of errors or noise in the data which has to be cleaned out, which is what we do in data cleaning process. I hope that answers your question, Vashist. All right. So yeah, so if we try to recap, the overview idea of what should be the data science project life cycle, it could be like this. Right. So you start with, we start with sort of step one is frame the problem, identify the problem. Are we trying to build a model to predict customer will leave or not leave, or are we trying to identify why cabs are delayed in Uber, things like that. Then the collect raw data needed for your problem. What is the data that we need from business, from non-business, from outside the world, from internet, from social media, other sources. Process the data for analysis, which includes cleaning, pre-processing, encoding, scaling of data. Then, right, so clean it and explore the data patterns. Then choose the right algorithm. There are multiple algorithms in machine learning, like linear regression, logistic regression, decision tree, neural networks, several machines like that. Choose the right model, which could be the right solution for your problem. And then finally, whatever model you build, communicate your findings and result of the analysis to the business team. This is how the whole process of data science problem gets into. Okay. So that's sort of idea. And yeah, so on that, exploratory data analysis is also one of the term which is more about exploring more patterns using visualization, right? And that might include a lot of stats and mathematics and visualization to explore more patterns from the data, which can help us decide that what is the right quality data to feed it to the model, right? Data wrangling is another very good skill that a data scientist needs to have. Wrangling is all about being able to identify that how can we utilize data with the right way. Maybe let's say that in form of data, if I am given with a parameter called date of birth. Now on the date of birth, I can't apply mean, median, or mode. There's no meaning of applying mean birth, date of birth, or median date of birth, or mode date of birth, right? We can't make sense out of that. So what we can do with date of birth is we can convert date of birth, we can subtract date of birth from the current date and create a new column which is resembling to age of the user. And based on age, we can apply mean, median, mode and make sense out of it. Right. So that's the idea of uh, data wrangling, which may include performing some computation or programming programming analysis on data to create valuable picture out of the whole data. Right. Which is what we do in data exploration visualization, as we've seen. And we're going to be talking about this tomorrow more on this. Yeah, so that's sort of idea about the whole idea of the overview idea of data science, the introduction to data science. So tomorrow in this session we'll going to be sort of dealing with this data set, and on the top of it we'll be using Python to perform some sort of exploratory analysis on data and clean this and use machine learning using Python. You'll use machine learning algorithms to build a predictive model to be able to predict customer will leave or not leave, like that. So that's going to be stuff that we're going to be doing tomorrow, right? So with this data set, and we'll end up here a little early today, maybe 3 minutes early, it seems. And yeah, but we'll be meeting tomorrow, spending more time and um, uh, solving this problem tomorrow with Python. Yeah, so the quick summary is about, we discussed about the data science overview, and we have discussed the sort of idea of, data science, how is data science, artificial intelligence, machine learning related. So artificial intelligence is a collection of algorithms which could be used to build intelligence. ML is a subset of it which deals with data. So all the algorithms from AI which use data to build intelligence are part of ML. And the most powerful set of algorithms under AI. Deep learning, another subset of ML, which does automated feature extraction. A subset, a segment which uses data to do analytics, which is statistics and probabilistic analysis, and visualization to analyze some patterns from data is called as data analytics. The combination of data analytics plus machine learning is what we call data science. Similarly, the combination, the field which deals with images and videos, here we say video without audio, is image processing. And the combination of image processing plus machine learning is computer vision. When we talk about applications like face recognition, or let's say building applications to recognize customer emotions from face, whether the customer is happy or sad from the face, recognizing objects, self-driving car, recognizing handwriting, are multiple applications of computer vision. Then the field wherein we deal with text or audio data is called as text processing, audio processing. When you combine that with AI or ML or DL, we call it NLP, natural language processing. Here we build ML on the top of text data or audio data. The popular examples could be speech to text, text to speech conversion, or Google's Cortana, Alexa, Siri. These are examples of NLP applications. Google search engine, right? Then chatbots. We deal with chatbots. We interact with chatbots on Uber, Zomato, Ola. All are example of NLP applications. Converting one language to another language. Automated subtitle creation on Netflix or Amazon Prime or YouTube. And uh, identifying sentiment associated with feedback from text. Classifying email as spam, not spam. Classifying email as primary or promotion or social on Gmail account. These are all examples of NLP. Right, so this is what the context we have seen. Data science is more about dealing with structured and semi-structured data, and on the top of it, applying statistical and probabilistic analysis, data visualization to identify pattern from the past data, right, where we identify what happened in the past. On the top of it, after applying ML, we can build a model which can predict what will happen in future. So this is the overview idea of the whole terminologies we talked about today. I hope that answers your question. So yeah, so with this part today we'll be ending up here, and the second part of this workshop will be continued tomorrow, right? And we'll be practically dealing with the problem tomorrow in that. So regarding the PPT, you can drop an email to the support team on contact@techtrunk.in, and you can get the PPT as well. Okay, so please drop his email at contact@techtrunk.in. Sure, I'll ask the team to do that. Right. So thank you all for joining today. See you all tomorrow in the session and practical dealing with Python and this data set. Good day and bye-bye. Yeah, so we're going to be doing Manish tomorrow session is going to be more completely practical session. Yeah, tomorrow's session is completely practical session, Manish. Okay. Thank you all for joining today. See you all tomorrow.